This is Lab 11, Detectors. I'm Owen Litz.
And I'm Richard Pang, and this is for our TA Lam Nguyen. This is part A. The goal of this part of the experiment was to measure the characteristics for the PIN photodiode, APD, and the photoconductor. And then we also measured the temporal characteristics for the PIN photodiode. These are results for the avalanche photodiode, and we can see a photodiode SNR of about 1, and for the avalanche photodiode, we see an SNR of about 4. And these are the results for our PIN photodiode. In the first graph, we can see VOC versus power. It increases sharply at the beginning and then levels off. For ISC, we see that it's a pretty linear graph. And then on the bottom left, we see a standard photodiode curve where you can see an inflection point. And then for our ISC, our ISC versus VOC curve, we can see that we kind of get a similar inflection point. However, it's less steep than we expected it to be. These are the results for our CDS photoconductor, and the first image is a photo of the CDS photoconductor, and the second is a graph of VOC versus power output for the photoconductor. These are the results for our PIN photodiode, where we measure the fall-off time from the peak to a value of 10% from the peak. And our first image is the oscilloscope reading for high impedance without the resistor. The fall-off time was about 16.4 milliseconds. And the second image is a oscilloscope reading for a 47 ohm impedance, where our fall-off time was lower and it was 1.7 milliseconds.
Part B, CMOS spectral and infrared imaging. The goal of this part of the experiment was to determine the effect of an IR filter on different types of light. An infrared source and a visible source were used. An infrared camera was used to detect the effect of an infrared lens and a concave meter later. These are the results for the lamp that emitted white light. On the left is the lamp spectrum without a filter, and on the right the spectrum with the filter. In this case, it's white light and visible mostly, so there's almost no difference in the spectrums and almost no difference in intensity either. Here are the results for the target card being illuminated with an infrared source. Without the filter on the left, the source is still visible and the spectrum is very broad. On the right is with the IR filter, and the spectrum is very narrow and almost no light is being imaged. Here are the results using the thermal camera. On the left, the IR lens is imaging the soldering iron at the focal point, and on the right, the soldering iron is being imaged through the IR lens. Here are the results using the mirror instead of the lens. On the left, the soldering iron is at the focal point of the mirror, and on the right, the soldering iron is being imaged using the mirror with a magnification of -1.